what we're going to be talking about today is still static analysis, but with a little bit of a context for security as opposed to resilience. I chose to do this because in the spirit of, yourself, the audience expectations, and also the excellent, agenda that the organizers put together, I thought it was only fair to also speak about static analysis. It's just that I don't have as much depth in using PHP Stan, which was the tool that Stefan was going to talk about, as he does. And I don't use it in the sense that for general resilience of Magento code. I am a security auditor. I do a lot of work when it comes to incident response in Magento and ensuring that Magento sites go out without vulnerabilities. So I definitely use PHP Stan, maybe from a little bit of a different perspective, but for security. And that's what we're going to focus today. You could think about this talk as a little bit of an introduction to what Stefan's talk was going to be, a little bit more introductory and more security focused. Stefan's slides on his Twitter are online. I'll grab a link. If you go to his Twitter account and you scroll through the tweets in one of his replies, or maybe reach out to him, he's very active on Twitter. He's already posted the slides. They get deeper than what we're going to be getting today. So hopefully I could do the topic justice. And we're not going to focus only on PHP Stan, but a little bit wider view of where static analysis fits into the development process. And I guess that's the basic introduction of trying to prepare you guys for what's coming up ahead. So first of all, mostly developers in the room, right? Any QA? Anyone? Oh, no, you're putting up your hand. Don't try that. I saw you. No, seriously. Do you work in QA for your team? Testing? Yeah, okay. So part about what I'm talking about today will probably put you out of a job, but it's not that bad. I guess most people are developers. Who writes tests for their code? Who's got full coverage? Yeah, there's one dude there. He's proud. I got full coverage. My question for you, right? How often this full coverage of your unit tests on your code, how often do you change it?
Honestly, not frequent enough.
Not frequent enough. That's exactly what I was expecting. Do you ever find that you go in, you're writing code, and you look at your unit test, and you're like, okay, I need to change this unit test. And you're like, wait a minute. This unit test should be covering 6 more different things, And then you're like, oh man, if I had a way to look at my code and just generate unit tests automatically, it would be really sweet. And it doesn't work. You need some sort of talent to translate what's written for code or what tests you've developed and write the code accordingly and not have a missing piece. Sorry? Sorry? And don't try it at night. Don't try it inebriated, So yeah, everyone knows that, unit tests and testing your code is really important, but getting that full coverage is rare, and keeping that full coverage up to date with what's happening, new requests from business, is even harder. And if you want to be one of those rarefied developer agencies that's on the ball all the time, not struggling to just catch up to what the client requests or your merchant business team requests, you need to have some sort of confidence in the testing of your code. So we already have something that takes complex data and automatically and quickly does something with it, and it's called computers. Computers are excellent at doing this. Taking complex inputs, doing some sort of processing, and giving you complex outputs. So at least let's talk about the PHP world for now. In the PHP part of Magento, the PHP compiler does this. Ignoring just-in-time compilers and the new stuff that comes out in PHP 8, which are all just optimizations on the compiler process. What the PHP compiler does, it takes the code you write, creates something called an AST. Oh, geez, I've forgotten what it stands for. Something tree. It creates a tree of what your code branch is, like what it decides to do, if conditions, loops, that sort of stuff. Sorry? Abstract syntax tree. Thanks, Niels. So it takes your code, creates an abstract syntax tree, so it's a kind of logical representation of your code. Then it takes that abstract syntax tree, and then it creates opcodes, which the Zend virtual machine runs. So Zend VM, you surely have heard of it. You've heard of Zend. That's the process of taking a really complex input, your code, and doing a bunch of processes to it, and having a complex output. This is what computers are really good at. So what if we take this complex input of code you wrote and take it from code to the abstract syntax tree, and then we have a tree that the machine understands, and then the machine could start looking for possible bugs in there before kicking out opcode that the VM is going to interpret and run. And this is where static analysis comes in. Static analysis is the process of taking a code and trying to understand it and understand where it may be broken. Static analysis covers a lot of things. A lot of its resilience, my focus specifically for my business, has been the security aspect of it. Which is why I was so disappointed Stefan was not here to give this talk, because I was so looking forward to learning more about how PHP Stand could possibly help my business. So that's kind of like a little overview of how static analysis works. To use this effectively means that you're going to start moving the breakages and the bugs in your code from production closer to development, because static analysis is going to run when you merge a PR, or maybe you run it on your own branch before you create a PR. It brings breakage and failure conditions off from production closer to the development part of the process. I think the term in the industry is moving errors left. So if you think left to right, which is our traditional Latin way of thinking, it starts on the left. So you're moving the discovery of bugs closer to the development process, which one is, at least when it comes to security, is extremely less catastrophic. Because think about it. If you have a security vulnerability in your code and you don't catch it before it goes into production, your site's going to get hacked. Then you're going to have to call me, and I'm not cheap. So you don't want to have security bugs rolling into production. But also, it's cheaper in the fact that when it comes to developer time, you are already in the mind space of building this new feature, or you're building, a modification to a new feature. It's cheaper in your mental space to look at that, get some results from a tool that says maybe you've missed a couple things in your complex code, for you to take that and implement fixes. So it's less stress for you, it's cheaper for your company, and all around it's always better to catch failures closer to development time. So the great thing about the new tools that do static analysis, back when I started, it'll just say, this stuff's bad, fix it. But the great thing about static analysis tools now is that they'll be like, okay, so this line's bad at this character, but here's some possible mitigations, and here's some recommendations for ways to fix it. Static analysis can become a learning tool for your team, and it's excellent. I've actually found once in my career where we run static analysis on a project, and new developers, people brand new to learning Magento, they get these errors and they're like, oh, so this is a learning process for them, and it helps you speed up your development, your developer, knowledge transfer learning significantly. And the nice thing about static analysis is that when you have a tool that looks at all your code and tries to figure out where there may be problems with it, it points directly to the problem. There's no saying, oh, well, you know what, our website has this problem. If you put in the SQL injection into this field, it breaks the site and you get access to the database. So like, so well, where do we fix this? Like where in, if you've ever seen a stack trace from Magento, there's like 7 files, or eight different, levels deep. Which one of these is broken? Or like, do we need to make a change to XML, PHP? Which file? Is it in vendor? Where is it? So the benefits of using static analysis is like, if it discovers a problem, it'll directly point you to this file. This is the file, this is the problem, here's a recommendation. I mean, that's like 10x engineer sort of shit. You can't get that easily without having somebody on your team looking at this all the time. Now, here's where I diverge a little bit from only the static analysis though. When it comes to security, you want to have something looking at your code and ideally integrated into your Jenkins engine and running automatically. But static analysis is not the only game in town, when it comes to security at least. In the field, what I use is static analysis and something called dynamic analysis also. These are 2 ways of looking at your code for possible vulnerabilities. Static analysis looks at all your code and like, okay, maybe this variable, the path we've seen this variable take and the effect it's having, if it's insecure, it may break something. But dynamic analysis is something completely different. Dynamic analysis like loads up the website and every input form, it throws as much bad, evil strings as it can to each one of those. So dynamic analysis does not look at your code, it looks at the final output and tries to break it. Those are the 2 heavy hitters of securing your website before it goes to production. And they work hand in hand. Back when I was learning about this, a long time ago, I'm not that young, in university they called it white box and black box testing, but in the field we are in, we try to avoid using colors to describe things. We don't call white list and black list anymore, we say allow list and block list. So now these are called static analysis and dynamic analysis. And it's much more descriptive, gives you an idea of what you're getting into. So if you see black box and white box testing, it's just an old way of speaking about it. We don't use those anymore. Static analysis and dynamic analysis, no one's better than the other one. They're both tools that work in synchrony. And one of the reasons I say this is dynamic analysis, when you have something scanning your site by throwing all the evil strings at it, it will help you find the false negatives that static analysis may bring up. So let's say you analyze your code, and Magento is a complicated system, and not every static analysis tool fully understands everything that gets into Magento. But it may say, look, you know what, you're not treating this variable securely, whereas you may have secured it above or below the execution stack. So what dynamic analysis says, so if the static analysis tool says you're not treating this variable securely, but you've protected it above and below, dynamic makes sure that failure condition is not an actual failure condition. So it kind of verifies your results. They go hand in hand. One will say you have a bunch of errors, and the other one's like, well, no, actually, it's not broken. Sorry, I need to refer to my notes. The only problem with dynamic analysis, if you're throwing a bunch of evil strings at your website to see which one's broken, at least in my experience when I do this for clients, it never pinpoints where the problem is. It tells you that something's broken, but it doesn't tell you where to find it in code. Whereas static analysis tells you exactly where it is and how to fix it, hopefully how to fix it. So ultimately, you do need both of them to properly secure any site that's going out. And if it gives you any hint as to how important static analysis is to the security of your code, on topic, the UK defense software, any software written for UK Defense Ministry by section 0055, they need to be analyzed statically. So any software for the UK Defense Ministry has to be written and analyzed statically before it's considered appropriate for the Defense Ministry. So It's that important. So you may be wondering, okay, I'm here selling you on the advantages of doing static and dynamic analysis on your code. How to get started? Unfortunately, a lot of the tools that do provide good static analysis are paid for. And as it comes with anything in the security industry, it's expensive. It's the websites you go to where you don't see a price. It's just like, get in touch with us for a quote, and then you get in touch with them, and they're like, how big is your company? Which Fortune 500 company you have? Okay, we'll just be adding some zeros to the end of this price. That's how security tools work. The ones I use, it took a lot of convincing to explain to them, look, I'm a small outfit, and I'm not, a Fortune 500 company. But there's good news. We have an excellent starting point, and I call this static analysis Lite, and it's something you probably all already familiar with, but don't realize you're running security static analysis on your code. It's called PHP CS, PHP Code Sniffer. Do you mind bringing up that the Adobe, the Magento? Yeah, the screen's not the best. There's a PHP coding standard that is on the Magento dev docs. Has anyone seen this before? Use it? Yeah. So if you drill down into the actual GitHub repository for the PHP coding standard and you start clicking around, there's an entire folder there for security concerns. So the tools that Magento provides you with PHP CS already covers like 5 or 6 common problems that may be security vulnerabilities in your code. And it also covers like a whole bunch of performance stuff and good coding practices and whatnot. You get it all with PHP CS. But it's a very light attack. It's a light defense mechanism when it comes to securing your site by analyzing your code. There are a couple as I said, expensive commercial software. One's called RIPS, R-I-P-S. It used to be free, but they've made it a subscription model with no price on the website. SonarCube, you need to have lawyers just to speak with that company, so it's a little bit, difficult to get in on that. And then, the bigger, more popular ones, then you'd start needing to get a building full of lawyers to speak with them. One free option is the Symphony Security Checker. Does anyone run the Symphony Security Checker on a regular basis? So a couple people. You mind pulling up the next tab with the screenshot? So Symphony, it's really simple. It's a composer include. So I don't have slides. Sorry, it's the best I can do. You do a composer include, a global include for Symphony Security Checker, command line, really simple. Like you guys could just Google it, and it'll spit out something like this. And it's like, well, CVE, common vulnerability, and I forget what the E stands for. CVEs, and it scans all your code, and it tries to track down any sort of recognized vulnerabilities that may exist in not only your code but also your vendor directory, and also those extensions, those somewhat sketchy extensions that some people purchase to run in their stores. This will scan everything, and it will grab every single extension and scan it for vulnerabilities. Symphony Security Checker, along with PHP CS, is like the first two things I look at when I bring on a new client that needs their code scanned. The last one I want to bring attention to, which was meant to be the main tool that Stefan was going to speak about today, is PHP Stan. There's no slide for it, but pretty easy to remember, PHP STAN. That has a less of a security focus. It's open source. There is also like a GUI you could pay annually for. It's called PHP Stan Pro. I pay for PHP Stan Pro. The main reason for it is because PHP Stan is incredibly flexible. You could write your own rules, and the thing about all of these static analysis tools is that they're only as good as the rules you put into them. So my my love for PHP Stan really comes from the fact that I could write rules specifically for things I've experienced in Magento that have been problems. And then the customizability of PHP Stan means that I could leverage an open source tool, support the open source community, and also have something that gives me the power to dig deep into this abstract syntax tree. It goes down, like some of the rules I've written, like tracks like 5 levels deep of like variables, where things are coming from, where they might be used inappropriately, and where vulnerability may or may not exist. So I've only been covering PHP for the last little bit, and that's where historically in Magento we've been looking for vulnerabilities in stores. But one other thing is JavaScript's becoming a big part of what the Magento world's doing. There are some parts of the Magento world who said, no, we don't want PWA Studio, and we're just happy with, Luma, Hoover, and we're just happy just doing the regular thing. But there are big companies, and there's a lot of people who just building stuff on React and whatnot. And putting that much business logic up onto JavaScript means you need to start scanning for that also. Obviously, the first option when it comes to using JavaScript is ESLint, Prettier, something like that. Those don't really pull out security concerns. There is one tool, and you guys can contact me later if you don't recognize this or need to get refreshed. It's called LGTM, and I think it stands for looks good. Sorry? Yeah, looks good to me. It's just like, it's a scanning tool that just like, if you've been a little bit lazy about, looking at your JavaScript. It's a paid tool, but it's really good at like tracking JavaScript errors that it's seen in other JavaScript code. So LGTM is one, and I think it relies on CodeQL, which is a GitHub endeavor. I can't remember 100%. So that's kind of the tools you could start easily bringing into your development process, start plugging into Jenkins. It doesn't need to be a one-way door that, the PR or the integration needs to fail if it fails all of the vulnerabilities, but it's good to have that insight where maybe it's something you start pinging your developers in your team saying, well, you know what, this may be a problem, let's see if we can get it fixed in the next one. And it's good to just ramp these things up, because in my experience, when you throw a whole bunch of errors at a development team and be like, you guys need to fix this. Here's like a 6-page PDF. Nothing gets done. It never gets done. It gets forgotten. Developers are lazy, which is a good thing. Developers are lazy and it just never gets done. So it's good if you integrate this into your Jenkins and just slowly ramp up the levels at which you run these tools, and also the amount of fixes you roll out to your developers. I want to start closing out with a little bit about the limitations of security analysis. First of all, it needs dynamic analysis side by side. You can't rely on one or the other. They go hand in hand. You need both of them to have some sort of complete solution. I wouldn't say complete solution, but a more complete solution to having confidence in your code. And it needs to be automated. If you're going to start running any sort of analysis on your code on a regular basis, it starts becoming an irregular basis, and then somebody switches teams, and then it's forgotten to be run, and then 3 months later, it's like, why do we have this? What's the point of this? And the repo just gets deleted. So it needs to be automated. You need to put it in Jenkins. If you don't have Jenkins or Circle CI or GitHub, Bitbucket, I can't remember what Bitbucket calls this stuff. Pipelines, yes. So if it's not integrated into your CI process, then you're not going to get the benefit of it. This is computers trying to secure your code, so you need to automate it also. The biggest drawback of using static analysis for security is that you get a lot of false negatives and false positives. So false positives is when the tool says, this is a problem, and you look at it and you're like, no, that's not really a problem. You just think it's a problem. And false negatives is that there's actually a problem, and it's like, no, it's fine. Because as smart as we've made computers, they're not infallible when it comes to understanding code. And someone's coding style may introduce something that the abstract syntax tree does not read properly into the analysis tool. So if you need to have an advanced developer on your team to be able to review this if it's going to become of any help to you. And as I mentioned before, these tools are only as good as their rules. Like if you have just the basic set of rules that they come with, it's going to do some sort of a job, but the thing is that you need to start building like a little bit more Magento focus rules to have the best effect. So it takes, again, more advanced developers. And I guess like if you have a smaller team, you probably get some advantage of using these, but you really need like, they're geared towards working with a little bit bigger teams or larger organizations. And the human element. There's a false sense of security that these tools give you, and I have to say this. If you have some computer scanning your tool, you start getting a little bit complacent, thinking, maybe, it's fine, the computer's dealing with it, I don't need to get involved. So there's always a false sense of security. There's things that these tools can't catch. Like, let's say you reuse a password on your production site. This tool's not going to catch that. If your configurations are trash, like, if you have something that's granting way too much permissions to one user or something like that, they will not catch this. So there's other parts of security that these tools cannot catch, but they're an important part of getting code that's more secure out there. And I don't understand my handwriting. So, skipping that point. So closing up. So security analysis is a powerful tool in the arsenal to give you confidence in your code. And if you employ them, you get the vulnerabilities found earlier rather than later, and you don't want vulnerabilities in your production side. It becomes really expensive. And if you provide enough good rules, they become invaluable, and they need the dynamic testing also and the dedication of your team. And that's it. I hope you're inspired to at least have PHP CS running in your Jenkins environment and your continuous integration, and have a little bit more confidence in the code that you put out. That's it. Do we have time for questions? No, we are out of time. So
Can you list down the tools again, like the LZTM, Symfony?
Grab me afterwards. I'll do it, and then we'll give the other speaker some time. So yeah, thank you guys.